Hi, good morning. We are here to test the welding sample. It has 5 zones: the high carbon area, low carbon area, heat effective zone near high carbon area, then the heat effective zone near low carbon area, and the welding zone. So we are now going to test its hardness on the Rockwell hardness tester. This is the C scale. This is first we use this because to test the hardness, how hard it is. If the material comes out to be soft, then we will go to that hardness tester wheels. Okay, now we are going to start. So we will place this sample over here. It should be flat surface. There should be no round. Okay. Now we are going to test the hardness over high carbon zone.
And we put the sample on the Rockwell hardness tester. Then it goes upwards. Close it.
The point where it touches, then we have to rotate this, and we have to see that this small point, this small pin should comes to that black point. Okay. And we have to count how many rounds it goes. It's first round. This is the second one, and now here it is. We have to make sure that this pointer should point between 0 and 5. So we have to adjust it by using this thing. So now it is set on 0, and we have to move this back.
It's the load. 100 kg. Once it stops, then we have to pull it backwards.
So now we can see its hardness. We have to check it on the black scale. It's 30 and this is 31. It's between 30 and 31, but it's near to 31, so we will count it as 31 HRC. HRC is because we are testing on hardness Rockwell C scale. So now let's take the reading.
We shall take 3 readings in order to have good accuracy.
It's 31 HRC.
This is
This is the high carbon zone. Okay.
Remove the lock.
Yeah.
Now we are going to test on low carbon zone.
We are going to test it on. So this L shows that it is low carbon zone. Here it is L. So you can see it's L here. Again, we are going to do the same procedure. Rotate this. When it comes to 0.
It's 3 revolutions now.
Yeah, it's 3 revolutions, and now it's between 0 and 5. So we have to make it to 0.0. Now it's good. Remove the load.
Count the revolutions.
We should not touch this until this pointer comes still, because it is going downward very slowly. Now it's still.
We will pull.
Now we can. Okay. Now we can see that it is showing the hardness of between 20, 21, 22, 23, 24, 25, and 26. It's between 25 and 26, but it's near to 25. So we will say it is 25 HRC.
So it's 25
At the low carbon.
HRC at low carbon.
Yeah, this is at low carbon zone.
Same thing goes for the welding zone and heat effecting
So
zone.
the same procedure we will do for the next 3 steps. For the heat effective zone area near high carbon, heat affected zone area near low carbon, and on the welding zone. This will give our 5 readings. Now we will go on that side to do some polishing.
Grinder. First we will go with this surface and then this. This is more rough surface, so this will make more smoother. Then we do it on more finer surface. We do it from all angles so that this doesn't go and makes more smoother surface. First we will remove this paper by unlocking this. Now we'll lock this, and same process for this. Before removing this, make sure that this is locked. So this all stuff goes in garbage. Now make sure that water is coming out of it. So you can see water level is good. So now we can start our grinding. We'll do it from all angles so that these lines, the fingerprints of these doesn't appear on this. So now we'll change the angle and do this. Looks like this is good, but we'll continue with a more finer surface on this. Again, change the angle of this. Yeah, looks like fine. So we'll close the water and now we'll start with the polishing pinch.
The basic idea is to get the more finer surface of the material. Now we'll go for the polishing now.
So first we're gonna start with the shade in there. And this is distilled water. And now this is alumina.
This is alumina for polishing.
Pour some meaning on the surface of the polisher. Then we're gonna rub the surface of the material on the polisher.
Now I'm gonna start. Make sure you hold this very tight because we're gonna slip that way.
One thing we have to keep in mind that the area which we are polishing, we don't have to touch it with our hands. And after doing that, we have to clear this with distilled water.
Change the side. Now I'm gonna get it on the side. Looks good. Now I'm gonna wash it with distilled
Now we
water.
have to clear it with distilled water.
Now you can see that the surface of this material is clear like mirror. You can see your face into this.
It's a shiny surface and it's just like a mirror.
We're gonna remove the impurities in it, so we just won't put it. Make sure you don't use your hand to put in that part. Right? And this is a nitrile. It's a 2% of nitric acid and 98% of methanol. And make sure you don't touch it with your hands. You don't drop it on your hands because it's gonna burn. And now we're gonna use this to put on it to remove impurities. So make sure you are careful by using
From this graph we can find properties of material. Now,
Give me a second.
40.
So just pour this acid for 40.
We have to put it on the surface of the material for 43 seconds. So here goes the timer.
So with the help of the dropper, we're gonna pour this acid on the surface of this to remove the impurities. So we have to pour by drop and not in much concentration because it's gonna cause corrosion or rust on
Close
that.
the bottom.
We have to now wait for 40 to 46 seconds.
It's counting. 10 seconds to go. After that, we have to clean with the distilled water, not with the regular water, because that gives the imprint of our fingerprints.
Alright, so again hold that with the help of this and then pour distilling water on it to make sure you don't use the normal water on it. Now it's clear.
As we now take the readings under a microscope. Here it is the PEX cam, and there are 4 contact lenses here. The higher the magnification of the lens, the higher we can get the reading of the sample under a microscope. Here it is the indicator, and we can rotate it from back and forth with the help of this. And with the help of this, sample is rotated from upside and down. And then
We have the eyepiece with the magnification of 10x, and the lenses we are having 4 lenses with different type of magnifications. It varies from 10x, 20x, 40x and 50x. So because the material is small and we want to take the grain size, so the grain sizes are very small, so we will take 50x. And when we take the 50x, the magnification will be 50x multiplied by 10x, it will be 500 times. So we will get very accurate and good magnification.
means the zoom will be the 500 times on the material.
Yes.
And now first we will take the reading on the high heat
Now-
affected zone on the high carbon side. And there is the picture. Here we can see the picture of the material under high carbon steel.
Actually, we have recorded earlier the pictures of that, and we have the samples. So this is the heat affected zone. It is showing very large amount of carbon, and it is showing small amount of rust because there might be some impurities on that. Therefore, this is the low carbon zone. It's a large grain size and equally distributed carbon grains. The white grains are called ferrite, and these black grains are carbon. So these are like large grain. You can see that this grain size is too large as compared to the high carbon zone. This is the welded zone. We can see that this is just a spider-like web. So much concentration of ferrite and carbon mix into each other. We can see that the carbon molecules, the carbon grains are more on the boundaries because this is the heat affected zone, and in the welded zone there is less carbon and more ferrite. There are long grains over here. Now this is the heat affected zone area near low carbon. We can see that there are small grains of carbon and large grains of ferrite, and carbon is distributed equally. So it's a very beautiful picture. This is the heat affected zone near high carbon area. We can see a lot of impurities over here. These are black spots. We can call it hot spots. There is a lot of carbon over here and small grains of ferrite and carbon. We can say that it is a pearlite.
Now I'm going to do the most important part of the lab. This is the discussion and the conclusion. I'll do the discussion and my friend will do the conclusion part. So here we come to the discussion part. Discussion includes that what kind of problems we faced in that, what kind of results were in there. So all these things come in discussion. So it has been seen that, as we can see here, higher toughness material will absorb more energy upon the impact and will therefore result in low height. So this is written over here. Now we can see that we compared only LH sample, carbon sample. This is low and high carbon samples. This is the all readings we got from the rock wall hardness test. Some of the readings were from C scale and some of were from B scale. B scale is a little bit soft scale and C scale is a hard scale. The materials which are soft, like steel, is a bit softer, so we can't measure on C scale. So those things all goes on the B scale. So here are the readings. High carbon side of the LH sample was 25 HRC and low carbon was the 97 HRB, because it is the soft material, so it is measured in the soft scale. So now we are coming to the welding zone. Welding zone was 24 HRC. Heat affected zone, it was 27 HRC, and heat affected zone with a low carbon side, it was 84 HRB, because it was also a soft material, so can't measure on the HRC side. So this is the wrong reading here. It only goes on the 84 HRB scale. B scale is a bit softer. Again, telling you the thing. Now we have to make a flow chart of this. This chart we made with the help of Excel thing. This chart we made with the Excel thing, and this you can see that this goes like this. This is the high carbon zone, low carbon zone, welding zone, and the very low carbon zone. So you can easily see that where the welding zone is there, the hardness is very high. So this is predicted that on the welding zone, the hardness is very high. So this comes to the end of the discussion. Now my friend will do the.
I want to conclude on behalf of my team that the high carbon zone area is a bit tougher and harder than the low carbon area, because as we tested on Rockwell hardness, it shows a good reading. After doing the whole process of etching, grinding and polishing, we took its pictures from the microscope. Its microstructure grains pictures were very fine. We can conclude that the pictures of high carbon area is very fine, the grains are very small and carbon is distributed evenly. Or whereas on the low carbon area, the carbon is very less and the grain size are very big. That's it. Thank you.